Okay, so we can start now. Hello everyone, my name is Marcin Kubacki, I'm Chief Software Architect at Storware, and in today's webinar we're going to discuss basic information about the containers, how they can be used. We'll just give you also a few examples. So I guess it's a very good start with this quite hot topic. So with me, there is Martin. Martin, if you could introduce yourself.
Hello, everyone. My name is Marcin Phan, and I am a solutions architect here with Catalogic Software. So I'm very excited to be presenting to you today, and thank you for the invitation for allowing me to speak on this topic of what are containers and how we can use them in our day-to-day development processes.
Okay, so maybe a short bio, if you could show to us.
Yep, absolutely. So again, that's a picture of myself over there on the left-hand side, by the way. So I've been working in the IT industry for much of it with Catalogic Software. So I've been a solutions architect, actually had many different roles here at Catalogic Software for most of my career. And with Catalogic Software, we're a data protection company so think backup and restore. That is headquartered out of the northeastern United States. So I've been working in the area of supporting, developing, implementing enterprise software backup and data protection solutions to help customers solve their backup and recovery challenges. And the title of my webinar today is titled, What are Containers? So it seems like only a short time ago, my manager asked me to read up on container technology. And the way he described it was, it's like a VMware or Hyper-V virtual machine. And of course, like any self-proclaimed efficient engineer, I said to myself, well, I'm already familiar with a lot of different hypervisor technologies, as I'm sure you all are as well, being in this open virtualization platform here. Why even bother learning another? It's just another hypervisor. It's just another programming language. It's just another, insert your redundant technology of choice that, if you already have a tool that you can use to solve it and you're already familiar with that tool, why not use that? So of course I put off learning about containers for as long as possible until it started appearing everywhere. It started appearing in our development workflows and even into our products, and users were asking us how they protect containers and how would their backup and data protection workflow change as a result of moving towards container technology. And that's when I realized that containers, while sharing some of the similarities with hypervisors and VMs, provide so much more efficiency than their VM counterpart. And that's what I hope to extend to you today, is that knowledge, and share with you some of the things that I've learned in my dealings with containers. So
Maybe just start with the simple answer. What are the containers? That our key question today. So a short comparison.
Yep, absolutely. So I'll tell you one thing, it's not like a VM, right? So VMs and containers do share some similarities, but let's start with the basics, right? While containers do share some similarities with being able to distribute resources from a server host operating system, machine virtualization, as depicted on the left-hand side here, more often or relies on a hypervisor layer to virtualize multiple guest operating systems. So in this case, you have VMware or Hyper-V machine running some hypervisor layer which acts as the operating system. And if you want to share those resources of CPU, memory, disk space, etc., from the underlying hardware component, you can deploy a virtual machine under the hypervisor, and all that virtual machine is its own self-contained operating system. So you might have multiple Windows machines running their own applications like store vProtect or a Catalogic DPX, for example, or a web server or a database server, but all that lives on the same hardware. Now, if you think about it, deploying code or configuring machines that if you want to share, the underlying hardware resources can be solved very easily with VMs, and that's why VMs have become so prevalent. You don't have to buy your own hardware per server or per function that you need. Containers, so you can think of containers as similar to VMs in that you can compartmentalize this underlying code, but it provides a much more lightweight and efficient means of deploying applications rather than deploying another VM. So in this world here, there are some hypervisor versions, desktop server versions like a VMware Workstation or Oracle VMbox. But do you really need that, Windows operating system or Linux operating system that's going to take up an additional, I think Windows at this point takes up an additional 30 gigs of storage to install just to launch your application. So this is where containers can come in to provide you with that lightweight implementation to compartmentalizing specific application binaries within a single transportable layer. So on top of the infrastructure, on top of the machine, you're going to have, your Windows operating system, your Linux operating system. But from this perspective, on top of the operating system, you're going to have a container engine. And in my example, I'm going to refer to Docker as a container engine because that's the most prevalent within the space. But Docker is going to allow us to provide and present these stateless machines, containers that will be able to compartmentalize applications and binaries and libraries. So those containers will actually share information from the host OS kernels, the operating system, the binaries, and the only thing that will be unique to the container machine itself is going to be the code that you want to deliver to your customer. So the name container is actually derived from a shipping logistic issue concern that was prevalent among cargo transport pre-1960. So imagine if you have some goods out there that you want to ship from point A, and these are the goods located up here. These products are varying size, and you want to be able to ship loose items, you want to stack them in crates, or you want to barrels, you're going to have different mechanisms or means to move those objects, right? So the logistics of shipping might include a truck, running on a road, or a train running on rail, ship running on over the sea. Each of these modes of transportation before the product reaches its final destination, and all these considerations need to be taken into account when you package your product, right, to reach your customer. Obviously, very inefficient, and it introduces what we call the matrix from hell, right? So having such logistical issues, moving transport or product from one place to another, how you do that, by what means you do that, is going to be a huge issue for customers. So what is the solution then, right? And this is actually where the term container derives its name. So the solution here, post 1960, was the intermodal shipping container, meaning I'm going to provide you with a standard object, right? A bucket to fill whatever you need to fill, right? So it's standardized across the board, and you're going to put your product into that container, and that container is going to be compatible with any different mode of transportation to get from that point. So it put the hands of or the responsibility of ensuring that the product was packaged correctly. It's not going to fall apart, break apart within the container, into the hands of the product developer, and then the transport mechanism in this case, as long as it was within that container, was going to be universal across the board, regardless of the product.
Okay, so now maybe let's compare this to the IT, because
Yep.
it's actually a good moment where maybe not real containers, but these virtual containers can be very helpful as well, I guess.
Yep, absolutely. So this plays well into the IT space as well. Remember, we're dealing with many different products, from operating systems, the applications running underneath it, and a large, let's say, payroll application might have many different components that support it, including a front end, a back end database, a website, API endpoints. All these different entry points or integration points into your product may vary depending on the product that you're trying to develop. Even more so, the way in which you deliver your product, is it running on-prem? Is it running on a physical machine? Is it running on a virtual machine? Is that machine running in the cloud or on a beefy desktop or user's laptop, right? So you take your product and you take the different modes in which that product can be delivered, and you end up with another matrix from hell, right? So how many times have you been working with your software application and you need to update a library, you need to update a database? You ask the question, does this work on a physical machine, or does it only work on a virtual machine? Can that virtual machine be deployed to the cloud? Those are the types of questions that users are asking today, and really all they want is that product functionality, what the software will help deliver for them. So that is where containers come in. So container is a shipping system for code. In this case, I can containerize my product functionality into a stateless machine, something that I know I can deploy the same time over and over again on varying pieces of hardware by just putting it into this container object. And you can see here that this icon represents Docker, which is the container engine that's responsible for running and sharing this application information with the host operating system that is the container engine Docker is running on. So this solves or eliminates the problem of the matrix from hell, because I know that if I package my code within a container, my web server, my database, my application backend, that container is going to work and run wherever I have a container engine deployed. So I'm very able to compartmentalize all the functions and features and provide the user with the flexibility to update any one of those features, or even provide myself with the flexibility of developing newer enhanced features into that logic very easily by just modifying the contents of the container.
Okay, so now maybe some real life examples. So I guess there is obviously a big company that uses it on large scale, right?
Yep. Exactly. There's actually a lot of customer or companies that are now using containers, realizing the flexibility of containers, not just in developing new and introducing new products to the market, but also in helping to service their customers. And one of the early adopters that we have over here in the States is a company called Netflix, and I'm sure you've all heard of it as well. They deliver and ship movies, allow people to watch movies and TV content worldwide. In fact, some stats here on the right-hand side. Currently have about 75 million plus members. The estimated third of all North American internet download traffic is from Netflix. So obviously, in order to handle that level of traffic and the amount of customers that are going to be watching these films, Netflix and its product team and its team of developers is going to need a way in which to not only enhance their code, but ship that product, excuse me, to their end user customer base. And containers provides them with the ability to do that. It gives them the flexibility to the application when that product is going from the cloud to a data center or a laptop without having to spin up and manage a bunch of VMs, right? Because as you spin up a VM, you know that you're going to need to manage that VM. In this case, the container can be spun up and torn down within a matter of seconds, just through the container engine, and it would help address, the scaling issues that come with dealing with this level of traffic and
But
customer base.
you said earlier about the stateless approach in many aspects of the containers, but what about the persistence of data, I guess, right? So this is very important aspect compared to regular virtual machine or physical box.
Correct. And that introduces a new problem for DPX as well and Catalogic Software, in that when we were specializing in data protection, we were looking at it from an agent-based approach. I'm communicating with the operating system, I'm communicating with the application, or I'm communicating with the hypervisor to take an agentless type backup. But containers were designed to be ephemeral, meaning they change, can be deployed with the click of a button and torn down at the click of a button as well. But in some cases, you might want to have that data persist. Let's say a database or an application that requires some static data to exist outside the container itself or be shared amongst multiple containers. In this case, what we have from a container perspective is this concept of a persistent volume. And this is a volume that lives outside of the container and is going to be tied to a physical piece of network storage. So think NFS, fiber channel, or iSCSI based storage that is not going to be impacted when that container is torn down or when that container is brought up. So obviously you're going to have multiple containers as well, potentially. And there are container managers in the form of Kubernetes, which was an open source project started by Google, has a big support forum and community. But as your container implementation grows and you're running multiple containers, you're going to move towards this container manager. OpenShift is Red Hat's implementation of Kubernetes. So it's think of it as a productized version that you can install in your infrastructure, but it comes with that paid support from the subscription, the Red Hat / IBM subscription. But it's easier to use for beginners, and it does provide you with some additional reporting features, such as configurable chargeback, monitoring, and centralized provisioning for automated container deployment. So just keep those in the back of your head as well.
Okay, so now let's jump to the other section of our today's presentation. So data protection for containers.
Yep.
So maybe if you could introduce first in general how such workflow works.
Yeah, so data protection is a problem that we've been solving for the past 20 years here at Catalogic Software. Remember, the data that persists throughout the container is going to be within this persistent volume. So all that resides in the container itself is the image of the application binaries needed to run the application. But at launch time, parameters can be passed to the container to configure components and map to those persistent data volumes containing such files as databases or configuration files that are needed within the container itself. So with containers, it's pretty easy to rebuild the application or the code and run a newer set of binaries. But in the event that you want to actually protect the persistent data, you're going to need to back up that persistent volume or the host operating system connected to that persistent volume. Now, how we've done this traditionally in the past with DPX at Catalogic Software is we would have to install an agent into that container VM to back up the data. And that is not so efficient, right? Because again, we're just treating it as any logical machine at that point. But we want to, if all we need to do is back up the persistent volume, we don't need the operating system or underlying application binaries because they can be recreated and reinstantiated very easily by redeploying the container. We just need that persistent volume. This is where we're turning towards products that can natively integrate in with container technology. And that's one of the reasons why Catalogic Software has actually partnered our development teams with Storware. So that's my introduction into Marcin to help us back up and protect the containers at the container management level. So we're interfacing directly talking with a Kubernetes or an OpenShift in order to back up that container data or persistent volume data.
Yeah, exactly. And if you look at this slide, there are several methods actually to protect containers. So agent was already mentioned, and it's frankly speaking, is a little bit against even the approach that is handled in virtual machines, because if you have tens or hundreds of VMs, then usually it's hard for you to manage such fleet of the agents at some point, and it consumes well, quite a large amount of resources as well. Then we've also noticed very basic, but also very effective in many cases, approach of sidecar pod. Depends a little bit on the implementation. So one approach is to just have a sidecar pod with every single deployment. Not very effective, and it basically affects the way you deploy your application. I said pod. It's very important to say maybe a little bit more about the pod. Okay, at this point, pod is a collection of containers that basically are not separate, but they act as a single entity. So for such environments like OpenShift and Kubernetes, you don't schedule, you don't run containers themselves, you run pods. So a group of containers, and each of these containers can have a little bit different application, but together they act as a single entity. So you can imagine that suddenly the pod somehow corresponds a little bit to the virtual machine. And the other approach is to have this pod or this container, let's say, deployed sort of globally. So you are just attaching persistent volumes and dump data on the file level base. So it's still agentless. It doesn't require you to deploy it every time with a specific group with your deployment, but still has some drawbacks. And especially one very important drawback is that you don't always want to back up everything on the file level based. You would prefer to have either native backup of your application like databases, or you would do snapshot based backup. Well, it's not obvious in the OpenShift or Kubernetes environments, as these were not prepared in the beginning to support snapshots itself. So you can try to snapshot volumes, persistent volumes behind the scenes directly with your storage. And obviously, you will not be able to implement every single storage that is on the market. However, there are already emerging solutions that they try to act as this intermediate layer. There is interface being prepared still for the Kubernetes and OpenShift that is still evolving, and this is going to cover up all of these different type of storage. But the most basic and also quite gaining popularity approach is just to use Ceph. Ceph as the storage provider for the not only for the containers, but also for the virtual machines and any other infrastructure deployments that we have seen recently. So basically, software-defined storage that is compatible. And for Ceph, yes, we support also snapshot-based backup in this case. So this allows you to have typical crash-consistent snapshot-based backup like for a regular virtual machine. Okay, so let's go on maybe. Now maybe.
Thank you for that, Marcin.
Yeah, and Catalogic. So it took me a while, but nevertheless, tell us a few words maybe how containers are being used on the other hand by the Catalogic, right?
Yeah, great point. It's actually a nice segue into the next topic here in our introduction into container technology. And how we leverage containers within Catalogic Software. So as I mentioned before, I mean, we're a software development company that has been specializing in data protection for over 20 years. And over those past 20 years, you could see the data protection landscape changing as people move from tape-based backups to virtual tape libraries, to cloud-based destinations, to block level incrementals, to agentless, to container technology. And container technology, as Marcin mentioned, really changes the dynamic in terms of data protection just due to their ephemeral nature. So as containers are being changed and you looking to back up and protect those persistent volumes, you're going to be reevaluating and your customers are going to be reevaluating that data protection strategy to focus on that persistent volume rather than backing up, let's say, the entire logical machine, which can be reinstantiated with container. So that's the reason why we partner with companies like Storware and their vProtect product to help provide that data protection platform towards protecting the container Kubernetes OpenShift environment. But learning about containers has also helped us refactor our product technology and product technology and our own development processes and workflows to quickly build and deploy modules in the field using containers. So again, we've been in this business now for the past 20 years. One of our flagship products is a data protection product called DPX, which was your typical application, Windows install shield, next, and it had its own set of components that would support the application. But as users would run into issues, we would need to send new service packs and new binaries, and it would break something else in another environment. So it was that matrix from hell, that we were talking about earlier. And with the advent of containers, we realized that we could compartmentalize the individual components that allowed our development teams to isolate product functionality. So this is how we're actually spinning up a new user interface. We've been through different user interfaces, from a FAT client to a Java client, to a web client, and now we're moving towards this HTML5 Angular client that needs to work with our backend databases and our backend modules. So we're compartmentalizing those components to communicate with the DPX backend that will also be compartmentalized within containers. And you can see this directly in our product now. Before, we used to deploy as install shield or as a Linux binary, and now we've moved towards an OVA deployment. So it's a VM deployment from which we can package the entire software component. But within that OVA is going to be the containers that we're using for each of the modules that support our new web UI, our new API gateway that allows that UI to run in parallel with the existing legacy user interface, but still be able to interpret and send those API calls to that backend, our traditional backend binaries. But it's only a matter of time before those backend binaries are going to be containerized as well. These images are going to be available from Catalogic Software directly. So if you're looking for a new version of the UI, you can update your container and be sure that that container is going to run with the other container images available on our Docker repository as well. And this also helps us, multi-thread our application as well. So rather than having to deploy, let's say, multiple versions of our DPX master server, which is a the control plane of DPX, we're able to containerize that process and then, as necessary, spin up a new virtual instance stateless machine to deploy and submit work to, rather than having a separate secondary server. So that's just some information for how we're using containers in DPX, and you can see all the DPX containers that are running within the OVA. Now, each of these has its own processes that it's running, libraries that it shares with the host operating system. But this is going to look and feel as a logical virtual machine with its own network stack and ports that it's listing off of, and you'll be able to rest assured that that'll be integrated in with the rest of the product.
Okay, so now I guess it's a good moment for a summary, and after that we'll have a short Q&A session.
So in summary, hopefully if you took one thing away from this presentation, it's that containers are not equal to VMs, right? So as my manager described to me earlier, this is somewhat of a unique construct in which we can very quickly and efficiently compartmentalize code, which can share the properties of the libraries of the underlying OS that we can ship and deploy on a very fast and scalable basis, right? So containers will allow you to scale your environment and improve your development operations. And as you move towards containers in your infrastructure, you can manage them through container managers like Kubernetes and OpenShift. And in trying to solve the data protection problem with containers and these stateless machines, obviously you don't need to back up the entire machine like you would a physical or even a virtual machine. In this case, you only need access to the data that persists outside the containers, the data on the persistent volumes. So that's, we partner with Storware to provide and help us develop towards that level of data protection. And hopefully this is enough for you to whet your interest and jump on the container bandwagon, because there are a lot of benefits that containers can offer above and beyond your traditional VM component. So I hope you do check it out, and I'll stop here for any questions.
Okay, so everyone, if you would like to unmute yourself, so you should be able to. If not, if you prefer to write a question here in the chat, you also can. So now it's a good time to ask some questions. Okay, so I don't see any questions for now. If you have any questions, just write to us. Martin, maybe you could share as well your email or something. And I guess that's everything for today. And stay tuned for the next webinar.